One important type of function that we often see when investigating one-sided limits are functions of the type that I consider to be of the type absolute x over x or x over absolute x. Now, I know that many of you look at this and say, oh yeah, I know the absolute value function. It's that thing that looks like a triangle. It's got kind of a point at the end, and that's true. I've written here y equals absolute x, in fact, does look just like I've written on the left side of this screen. But that's a different type of function. Let me show you why. If we write out some values, it'll become more apparent. So if you consider, for example, the value x equals 1, then absolute x over x is just going to be the absolute value of 1 is 1, and then 1 is 1 itself, and that's going to be 1. So you say, oh, well, that's easy. That's because I chose x equals 1. Well, let's choose x equals 0.2. Well, the absolute value of 0.2 is 0.2, and of course, 0.2 is equal to 0.2, so that's also equal to 1. So it seems that what we're getting is a function that's just going to be the constant 1. In fact, if I put in 1,000, then I get 1,000. That's the absolute value of 1,000 divided by 1,000 itself, which is 1. But look what happens if I put in a negative value, like say negative 1. The absolute value of negative 1 is just 1, and negative 1 itself is negative 1. So this is 1 over negative 1, which equals negative 1. If I put in negative 0.001, then that comes out to 0.001. That's the absolute value of negative 0.001 divided by negative 0.001. Divide those and you get once again negative 1. So this is a function that actually is equal to that's equal to 1 or negative 1 depending on which side of 0 you're on. So what this function actually looks like is, let me just draw it here, y equals absolute x over x. What this function actually looks like is more like this, is it's going to be equal to 1 when x is positive, and it's going to be equal to negative 1 when x is negative. That's negative 1, that's positive 1. And of course, at 0, since you can't divide by 0, the function is actually itself undefined. This is sort of the useful example in the case of one-sided limits, because what we can very easily see here is that the right side limit, looking at where the ant is crawling, is going to be different from the left side limit. The ant would conclude it's going to end up at 1 if you approach from the right, or at negative 1 if you approach from the left. So what we'd write here is that the limit as x approaches 0 plus of absolute x over x is equal to 1, and the limit as x approaches 0 minus of absolute x over x is equal to negative 1. So what we want to do is rewrite this function f of x equals x plus 3 over absolute x plus 3 as a piecewise function and evaluate both its right-hand and left-hand limits as x approaches negative 3. We can tell that negative 3 is going to be kind of the sticking point where the function might have different right and left-hand limits, because partly because that's where we'd get division by 0 here, but also because we know that that's where an absolute value function, absolute of x plus 3, is going to change definition where the expression inside that absolute value is going to be equal to 0. So what we want to do is think about how we rewrite this as a piecewise function. Say absolute x plus 3, sorry, no, the absolute is on the bottom, so x plus 3 over absolute x plus 3 is going to equal, for values that are greater than negative 3, it's simply going to equal x plus 3 over x plus 3, which equals 1, as long as x is greater than, or actually I should say not equal to, because we can't do equality. X is greater than negative 3, and on the bottom, on the bottom of this case function, we can say that if x is less than negative 3, then this is going to equal x plus 3 over that absolute value expression, then becomes negative x plus 3. If I take x plus 3 over negative x plus 3, I get negative 1. So this is kind of the analytic way to do that. So what we have here is a case function that's going to be equal to 1 for x greater than negative 3 and negative 1 for x less than negative 3. So now I can write the limit as x approaches negative 3 from the positive side of f of x is equal to, I'll change it to a contrasting color. There we go. Is going to be equal to, I only care what's going on since this is the positive side of negative 3, I only care what's going on for values that are greater than negative 3. I'm just drawing a quick number line up here, which means I only care about that. So this is just equal to limit as x approaches negative 3 plus of the constant 1, which is of course 1. And I do the reverse thing on the other side, x approaches negative 3 minus. Notice how we're overloading these terms. I've got two minuses in this limit, where depending on whether it's before the 3 or after the 3, it has different meaning. The one before means that it's negative 3 instead of positive 3. The one after means I'm approaching from the left side. So it's this gives us f of x is equal, limit as x approaches negative 3 from the left side of f of x is equal to the limit as x approaches negative 3 from the left side of the left side definition, which is negative 1. And those are, in fact, our answers using this technique.